friends, welcome back to our channel Abhi Chemistry Tutorial. So in this video we are going to learn about Bamford-Stevens reaction and Sharpio reaction or Tosylhydrazone decomposition. So we are discussing the organic naming reaction series, and in this series we have already posted a lot of videos. So if you have not checked the videos in this organic naming reaction series, so kindly check the playlist link given in the description box. And also we have a lot of other videos which will be useful for your studies for SCS and NET exams or for MSc exams. So before going to the video, if you have not subscribed to our channel, please take a second to subscribe to our channel, because many people are watching our channel without subscribing. So nearly 99% people are watching without subscribing. So only very few people are watching by subscribing. So please take a second to subscribe and share to your friends, since you are getting benefited from my videos. So please support me with your subscription. It's a small thing you can do so that I will be motivated. So it will make my day to push myself to make more such videos for you, so that you can also study with my videos. So now let's get started. So Bamford-Stevens reaction and Sharpio reaction. So the reactions involving carbene and carbocation intermediate. So these two reactions are almost similar, except the base used in this reaction. So these reactions involves two types of paths so that we get the product. So the first type is the carbene intermediate and the next one is the carbocation intermediate. So what is Bamford-Stevens reaction and what is Sharpio reaction? You can say in common, tosylhydrazones of an aldehyde or ketone reacts with a base to form an alkene. So tosylhydrazones of an alkene or a ketone with a base will give an alkene is called Bamford-Stevens reaction and is called Sharpio reaction. So these reactions involves two pathways. One is carbene intermediate and one is carbocation intermediate. So we learnt we are going to react the tosylhydrazones with a base. So the base used differs. So if the base used is a strong base like sodium ethylene glycol, sodium hydride, sodium methoxide and sodamide, the reaction will be said as Bamford-Stevens reaction. In the same way, if the reaction uses a base like alkyl lithium reagent, that is organolithium reagent or Grignard reagent, the reaction will be said to as Sharpio reaction. So the only difference between Bamford-Stevens reaction and Sharpio reaction is the base employed. If the base is a strong base like sodium ethylene glycol, sodium hydride, sodium methoxide, sodium sodamide, it is Bamford-Stevens reaction, and if it is an organolithium compound or a Grignard reagent, it is Sharpio reaction. The alkenes formed in this reaction are generally less substituted kinetic products, and here you can see this is a tosylhydrazone compound. When base is employed, it forms an alkene. So this alkene we get is the major product and this is the minor product in this reaction. Although the base employed are different, both the reactions will have two types of mechanisms or two pathways. So this depends upon the solvent used. So in case of aprotic solvents used, we can see carbenoid mechanisms, and if we use a protic solvent, we can see carbocation mechanism. So what are protic solvents? That solvents which can release H plus into the reaction is called protic solvent, and which cannot release H plus is called aprotic solvent. So the protic solvents follows carbocation mechanisms, and aprotic solvents if aprotic solvents are used, it follows carbenoid mechanism or carbene mechanism. So both the routes have a diazo compound formation, which you will learn in the mechanism. So in general, how can you represent the Bamford-Stevens reaction or Sharpio reaction is, this is a tosylhydrazone When it is treated with a base, we get an alkene. So here we have taken two carbon atoms, which is substituted R1, R2 and a hydrogen, and here R3 and a double bond Tosylhydrazone part. So here you can see if this R3 is an alkyl group, it will be a Tosylhydrazone of ketone, and if this R3 is a hydrogen, then this is a Tosylhydrazone of an aldehyde. So in general, the Tosylhydrazones when treated with a base will give an alkene. Now we will learn the mechanism. So first we will go through the aprotic solvent. So if aprotic solvent is used, we can see the Carbine Oil Mechanism, where carbene will be produced as the intermediate. So it involves 5 steps. That is, the Carbine Oil Mechanism involves 5 steps. So the first step is the abstraction of proton by a base. So base is always OH minus, as you know, and this will abstract a H plus from the compound. So here you can see it will abstract a H plus from the hydrazone's nitrogen, and this nitrogen will get a negative charge over this. And the next step, step 2, is the removal of tosyl group in the slow step. So usually what is a slow step? It is the rate determining step. So this slow step removes the tosyl group from the compound. So how it takes place? So this nitrogen will have a lone pair of electron on it. This lone pair of nitrogen is shifted here to form a bond between these two nitrogens, so that this nitrogen now is deficient of electrons, so it will have a positive charge over it. And here you can see this nitrogen has its charge satisfied, so this tosyl group is removed as tosyl minus ion. So this is a diazo compound. So step 2, until step 2, it is the same for both carbine oil mechanism and carbocation mechanism. So next is the step 3. This involves the removal of nitrogen to form carbene. So how it happens? So diazo compound is here, and here you can see we have a negative charge over this nitrogen. So this is shifted here to form a bond, and so that one of these double bonds is shifted over this carbon, so that this carbon will get a negative charge over it. And next, this bond will have 2 electrons, and both the 2 electrons, that is the whole bond, is shifted over this nitrogen, so that this nitrogen will get back its lone pair of electrons and the nitrogen molecule is removed. So now this carbon has a negative charge, and this negative charge has 2 electrons, and here you can see the carbon has 2 bonds and it has 2 valence electrons not filled, that is, it has 2 more. It has the capability to form 2 more bonds. These 2 bonds are not formed here, so it has 2 electrons, and this structure is called carbene, and this form of the carbon is called carbene. So next is the step 4, that is the removal of H plus from the carbene to form carbanion. So here you can see this is the carbene with 2 electrons in the carbon, and now the H plus is removed from the nearby carbon, and this bond is shifted here to form C double bond C. So now one more bond is satisfied, that is 3 bonds are formed for this carbon, and it needs only one more bond. So these 2 electrons again forms negative charge, and this is the carbanion. And the next is the step 5, that is the final step, and here it involves addition of water to form alkene. So addition of water always exists as H plus and OH minus, and here we have a negative charge, so this H plus is attached to this negative charge to form a bond. So this forms an alkene. So this is the final product, and this is the alkene formed through carbine oil mechanism from tosylhydrazones. So next we have another mechanism, that is carbocation mechanism, if we use protic solvents. So here we have used protic solvents and the carbocation mechanism is explained here. So as I said before, step 1 and step 2 are the same until we get the diazo compound. So if you have already noted the step 1 and step 2, kindly verify the product in the compound we got in step 2 is this diazo compound. For confirmation, I will show you that. So here you can see in the step 2, after removal of the tosyl group in slow step, we get a diazo compound. So this compound and this is the same, as you can see. And now this diazo compound is going to do some rearrangement in itself, and a H plus from the solvent, that is from the H plus from protic solvent, is also involved in this step. So let us see how. So this negative charge shifts over here to become a triple bond between the nitrogen atoms, and so that one bond of this double bond is shifted over this carbon, so that this carbon will get a negative charge. So this negative charge will abstract the proton from the solvent to form CH bond, as you can see here. So this will be the third step in this case. And the next step is, this bond will already have 2 electrons, and these 2 electrons along with this bond is shifted over this nitrogen, so that the lone pair of nitrogens are returned back to the nitrogen. So this will remove as nitrogen molecule, so that the carbon has no electron left over and it will get a positive charge here, as you can see here. So this is a carbocation. Since the bond is completely shifted with the 2 electrons over this nitrogen, the carbon is deficient of electron, so that we get a positive charge. So that is a carbocation. And now this H plus is removed and this bond shifts over here to form a double bond, as you can see. So this will be an alkene. So this form is alkene, as you know. So this is a final product we got through carbocation mechanism in Bamford-Stevens reaction and also in Sharpio reaction. The only difference is the base employed. So this is all about Bamford-Stevens reaction and Sharpio reaction, or you can say Tosylhydrazone decomposition. So I hope the video is useful for you. So please like the video and don't forget to subscribe to our channel and also press the bell icon, so that you will be notified whenever I upload a new video. So many other naming reactions are waiting for you. So please make utilize of all the videos. Please share to your friends and see you all in the next video. Until then, bye. Thank you.